Okay, we're going to talk about graphing lines using slope-intercept form. Okay, a couple things we need to remember with these key terms is slope. All right, remember slope represents rise over run. All right, the y-intercept. Okay, we talked about the y-intercept is when x equals 0. Okay, it's where the line crosses the y-axis. Okay, slope-intercept form is function form. All right, kind of function form. All right, slope-intercept form is written y equals, but it's y equals mx plus b. All right, and we'll talk about what m and b represent later. The last key term is parallel lines. If you remember from previous sections, parallel lines have the same slope. All right, and the symbol for parallel lines is two lines side by side. Okay, parallel lines will have the same slope. All right, slope-intercept form, also known as function form, where we have y equals. Slope-intercept form is most commonly referred to as y equals mx plus b. All right, where the value for m is the slope of your line, and then b is the y-intercept. Okay, the y-intercept, or where the line crosses the y-axis. So, looking at a picture here, we have, draw a quick line here. So our slope of the line will be its rise over run. Okay, and then the y-intercept is where the line crosses the y-axis. If you look at this line I just drew, the y-intercept is right there. And that's at 0, 3. Okay? Alright, and then the slope, we'll find another point on our line, and the slope is the rise to run ratio. Alright, the run meaning its horizontal change compared to its vertical change. So the slope is 3 over 1, or just 3. Alright, we're going to say it's positive slope because it's going up from left to right. Alright, so if we look at our examples, the slope for y equals 3x minus 2 is 3, and the y-intercept is negative 2. The slope for negative 5x plus 8 is negative 5, and the y-intercept is 8. Okay? The slope for 2/3 x plus 10 is 2/3, and 10 is the y-intercept. Alright? And remember, y and x represent all the coordinates, the ordered pairs that are on our line. Okay, so let's graph by using slope-intercept form. Alright, we have the equation y equals 2x minus 5. Alright, the first step is we're going to find the slope. In this case, the slope, alright, we're going to go off the standard equation here. Y equals mx plus b. The slope, m, equals 2. Okay, or 2 over 1. Alright, the second step is plot the b. Alright, what is our b? What is our y-intercept? Alright, the y-intercept is negative 5. B is negative 5. So we're going to plot 0, negative 5. 0, negative 5. We're going to plot that point. Step 3, use the slope to plot the next point from B. Alright, so from our y-intercept, we're going to use the slope to plot the next point. Alright, by doing this, we're going to use its rise and its run. So we're going to rise 2, and we're going to run 1 from that point. Rise 2, run 1, we have our next point, okay, from B, and our B was -5. Alright, step 4, draw a line through the 2 points. Alright, we have our 2 points, okay, and that's all we need to make a line, so we're going to draw a line through the 2 points. Alright, and that's the graph of our equation y equals 2x minus 5. Alright, let's look at another example that's not readily written in y equals mx plus b form. Okay, so the first thing we're going to do is we're going to find the slope, but we have to get it in slope-intercept form first, or function form first. So we have to get y by itself. Alright, so we have to get rid of this 2x first. So we have 3y equals -2x plus 6. And I wrote the -2 first because I want it to look like y equals mx plus b. Divide by 3 to get rid of the 3 from the y. And I'm left with y equals -2/3 x plus 2. Alright, so now I have it in slope-intercept form. The first step, remember, is to identify the slope. In this case, m is 2/3. The second step is to plot the b, or the y-intercept, which b equals 2 in this case, so we're going to plot 0, 2. So I'm going to go to 0, 2 on my y-axis. The third step is to use the slope to plot the second point. Alright, so b is 2. Alright, we're going to use the slope. The slope in this case is -2/3. So we're going to rise -2, and we're going to run 3. Now, since it's negative, alright, our rise is actually going in the opposite direction. It's going down. So we're going to go down 2, and we're going to run. It's positive. Our run is positive 3. Okay? We can plot our second point there. Now, if you came into the situation where you had 2 over -3, that's the same thing as -2/3. Okay, and I'm going to show you that. If we start from our b and we go up 2, our run is -3, so we're going to go left 3. And we can plot our point. And if you notice, when you make your line, it still goes through all the points. Okay, so either way you could use that slope. Alright, and that was the fourth step, draw the line. Alright, parallel lines have the same slope. Okay, so if you want to determine, are these lines parallel, well, you have to find the slope for each line. Alright, so let's look at our first group of equations, and then we have y equals -3x plus 2. Well, this is in slope-intercept form, y equals mx plus b, and our m is right here, so our m is -3. Our slope is -3. Alright, let's see if our slope in the other equation is -3. Well, this equation is not in slope-intercept form, So we have to get y by itself. Get rid of the 3x by subtracting 3x. Do the same thing on the other side. Y equals negative 3x minus 4. Alright, now it's in slope-intercept form, and our m is negative 3. So we got the same slope for both lines. Alright, so these lines are parallel. Let's look at our second group of equations. Okay, we have 2x minus 5 equals negative 3. I'm going to split these up and solve for y in both. Alright, so the first one I have to get rid of the 2x. Left with negative 5y on the left. Oops. I have negative 2x and minus 3 divided by negative 5. And we get y equals negative 2 divided by negative 5 is 2 over 5. X. Negative 3 divided by negative 5. Negative divided by negative is positive. And I'm just going to leave it as a fraction because that's not what's important. What's important is the slope here in determining whether or not they are parallel. So the slope of our first line is 2/5. Let's check the second out. Get rid of that 5x. And we're left with 2y equals negative 5x plus 6 divided by 2. And you get y equals negative 5 over 2x plus 3. Just found that trap. 6 divided by 2 is 3. And we get the slope, in this case, is negative 5 over 2. So are they parallel? Nope. They're not the same slope. Alright, what you're going to learn in further lesson is that they're actually perpendicular lines. We'll talk about that later. Alright, try a couple problems on your own.